Imagine jumping from Earth to the other side of the galaxy. Not in centuries, but in minutes. No more generational starships, no frozen sleep pods. Just a flick of a switch, and bam, you're light years away. Sounds like science fiction, right? Hyperspace, warp drives, jump gates. We've seen them all in movies and shows. But what if this seemingly magical shortcut through space isn't just fiction? In this video, we're diving deep, past the pop culture tropes, into the real science behind hyperspace. We'll explore why the universe doesn't like things going faster than light, the loopholes scientists are chasing, and whether hyperspace might one day become real. So, buckle up. This isn't your average sci-fi breakdown. This is the story of one of the most mind-bending concepts in physics, and how it might shape our future. Hyperspace isn't just a cool sci-fi term. It's a clever workaround. The idea is simple. Instead of traveling through the regular three-dimensional space we know, what if you could dip into a higher dimensional space where the rules are different, where distances are shorter and light-speed barriers don't apply? In fiction, hyperspace is like an express lane. Your ship enters a different dimension, zips across massive distances in no time, then pops back into regular space. It's how the Millennium Falcon crosses galaxies in hours, or how jump gates work in Babylon 5. But what is it really? In mathematical terms, hyperspace is any space with more than 3 dimensions. Theoretical physicists propose extra dimensions in models like string theory, up to 11 of them in some versions. Most are curled up or hidden from our perception. But what if we could access them? Imagine folding a piece of paper. If you could punch through the fold, you'd travel from one side to the other without crossing the surface. That's hyperspace, a shortcut through a dimension we can't see. It's speculative, yes, but not pure fantasy. Higher dimensional spaces are used in real math and physics, and some cosmological theories suggest our universe might be a 3-dimensional brain floating in a higher dimensional bulk. If we could move through that bulk, hyperspace travel might not be so far-fetched after all. Long before warp drives and jump gates hit our screens, hyperspace was born in the pages of pulp science fiction. In the 1930s and 40s, writers like E. Doc Smith and John W. Campbell started using hyperspace to solve a narrative problem. How do you travel vast interstellar distances without boring the reader or waiting centuries? The answer? Step outside the universe. From there, hyperspace became a staple. Isaac Asimov's Foundation series used it to power the Galactic Empire's transportation network. Star Wars made it flashy with streaking stars and unpredictable jumps. Stargate added wormhole networks. Babylon 5 made it eerie and unstable. But even as fiction evolved, hyperspace stayed largely symbolic. It represented transcendence, the unknown, and the human drive to overcome limitations. Writers weren't just using it as a plot device. They were tapping into our deepest curiosity. What's beyond what we can see? Interestingly, as real physics advanced, sci-fi kept adapting. Writers like Arthur C. Clarke and later Alastair Reynolds began blending actual scientific theories into their stories. Hyperspace became more than magic. It became plausible. And that's where things get fascinating, because fiction started to shape the questions real scientists were asking. Could hyperspace, or something like it, exist? Here's the hard truth. Faster than light, FTL travel breaks the rules of Einstein's relativity. As you accelerate an object with mass, it gets heavier, figuratively speaking. Pushing it faster takes more energy. Near light speed, you'd need infinite energy to go faster. That's a non-starter. Time dilation also kicks in. As you move faster, time slows down for you. At light speed, time would stop completely. That's why photons don't age. But if you had mass, even a grain of sand, you couldn't join that party. And then there's space-time. It's not flat. It's curved by mass and energy. That curvature makes space dynamic and tricky to navigate. You can't just draw a straight line between 2 points and expect it to work. So where does that leave us? FTL travel, if it's ever possible, must involve bending space-time, not brute-forcing speed. That's where ideas like hyperspace come in, a way to shortcut space instead of outrunning light. But even those ideas need exotic matter with negative energy. We've never seen such stuff. We don't know if it can exist. And if it can, we don't know how to make or control it. Bottom line, the universe is built to prevent FTL. But we humans, we love breaking rules. Because real physics says, nope, science fiction gets clever. Take hyperspace lanes. In Star Wars, ships jump through mapped-out routes to avoid crashing into stars. That adds realism and risk. You can't just jump anywhere. You need charts, navigation, and luck. Other stories use jump gates or wormholes to pre-map safe routes. Babylon 5's jump points are artificial openings into hyperspace. Stargate's wormholes are ancient technology. These act like portals, bending space without breaking physics too hard. Some universes make hyperspace dangerous. There are monsters, or storms, or madness. That adds tension. You're not just skipping through space, you're gambling with reality. These creative tweaks do more than entertain. They reflect our real fears and hopes about exploration. Hyperspace becomes a metaphor for the unknown, for risk, for ambition. And crucially, they help audiences accept wild concepts by wrapping them in rules. That's what makes science fiction powerful. It feels real, even when it isn't. Now let's get weird. Some physicists believe our universe is a three-dimensional brain in a higher dimensional space called the bulk. If true, other brains could exist. Parallel universes just inches away, but unreachable. What if we could punch through the brain? That's the basic idea behind some hyperspace theories. Traveling outside our space to move faster inside it. Think of folding space, like a wormhole or a warp bubble. Miguel Alcubierre's warp drive concept, for instance, doesn't move a ship faster than light. It moves space itself. A bubble contracts space in front of the ship and expands it behind. Inside the bubble, the ship coasts peacefully. Problem? It needs negative energy, a kind of exotic matter we haven't discovered. Other ideas involve quantum tunneling, manipulating zero-point energy, or tapping into dark energy. All highly theoretical, all insanely ambitious. But here's the thing. Some of today's real science sounds like yesterday's science fiction. Black holes were once considered fantasy. So were gravitational waves. Now we observe them. So maybe, just maybe, hyperspace isn't impossible. Just really, really hard. Hyperspace isn't just a fictional trick to move starships. It's a window into human imagination, and maybe into the deeper structure of the universe itself. Right now, it's beyond our grasp. But ideas like extra dimensions, warped space-time, and even alternate brains aren't just science fiction. They're on the cutting edge of theoretical physics. Maybe someday, the stars will be closer than we ever imagined. Not by going faster, but by changing how we think about space and time. Until then, hyperspace is a dream, a bold one, a beautiful one. And like all the best dreams, it might just lead us somewhere incredible.